Welcome and thank you for joining our webinar today, Expert Tips and Techniques for Closing Unix Linux Security Gaps, featuring guest speaker, Information Security Trusted Advisor, Ron Warner. You're also joined by Beyond Trust David Grins, and after Ron's portion, David will run us through a brief overview and demo, if we have time, of Beyond Trust PowerBroker Server Suite, so please stick around for that. My name is Sarah, your webinar host today. Hello, everybody. A kind reminder to please submit your questions via the GoToMeeting console anytime throughout the webinar, and we will cover your questions at the end during our Q&A time. So you'll find it in the right side of the console with the little questions section, and you can go ahead and submit your questions throughout. Also, today's session is being recorded, and you will receive a follow-up email containing links to the recording and the slides shown here today within 1 to 2 business days from now. Additionally, the slides can be downloaded right now via the handout section in the GoToWebinar console. Additionally, if you are attending for CPE credits and have an ISAACA account, you can download the attendance verification document in the handout section now in order to submit proof that you attended today's session. So please note that you're responsible for reporting your own CP hours earned to ISAACA. Okay, now that all of the housekeeping items are out of the way, let's hand it on over to Ron, who's going to jump right in. Ron, you ready to take on this crowd today or what?
Let's do it, Sarah. Thank you so much for a great
Nice.
intro. Good morning, good afternoon, good day to you all. Thank you for joining me on this adventure through Linux security. I'm Ron Werner. Couple quick facts about me related to this talk. First of all, early in my career, I actually worked with Thompson and Ritchie. They're the guys who created Unix at AT&T Bell Labs. Kind of grew up in New Jersey, so it was easy to get a job there, and ended up meeting and working with them, which was awesome. Second of all, I actually created my first Unix security checklist in 2000. Back in the day, as a Linux Unix sysadmin, we didn't have a separate security department. If we wanted to secure our stuff, we learned how to do it ourselves. So I did it, created a checklist, and actually this talk is based on it. While the commands have changed, the concepts and process hasn't. So what are we doing here? Well, the majority of internet web systems run on some form of Linux. Are they all sufficiently secure? Good question. That's what I'm here to talk with you about today, the process and some of the commands to lock down Linux systems. My objective is to provide you with some nuggets on how to secure Linux systems in your world. There are many different flavors of Linux. The different OSs are called flavors, which you see on my screen. I'm fairly agnostic when it comes to my favorite. In this talk, I'll be using Ubuntu, mainly because that's the easiest for me to run on my VM. But you might just have a different one that you use at your home or with your work. So pick the flavor that you want to use, learn the commands specific to it, because there are some differences, which I'll be showing through this talk. During the next 30 minutes or so, I'll be providing you with the process for setting a secure baseline for your Linux systems. I'll address common issues with what's called IAAAA, identity, access, authentication, authorization, and auditing, and finishing with some ideas on how to automate. There's a lot of manual techniques. So wouldn't it be nice if we could just automate what we're doing and then ship it out to all of the Linux systems in our environment? I have a lot to cover, and we'll be moving very quickly. Some of the things I'll be glossing over in the interest of time, so I can spend time on the good stuff. If you have questions, please ask through the chat. A few caveats to start. First of all, if we have any Unix sysadmins who have been around for a while, some of these things are going to seem like, oh, duh, Captain Obvious. What I've learned, though, is sometimes we miss the basics, the basic blocking and tackling, to use a football term, the basic of how to dribble a basketball. We need to make sure we're covering those basics. Shouldn't just assume that they are being done. So I have this phrase that I use called check your assumptions, CYA. No, not that, CYA. So don't just assume you're doing the basics. Actually go through and make sure that they're all being accomplished. Few more caveats. Your mileage may vary. This is a security checklist that I have. I'm providing you with food for thought. The choice is up to you as to what you do. The idea is to balance security with usability and functionality. I'm not going to be able to cover everything. I have this feeling someone's going to come back and say, you missed this. And I'll probably be like, yeah, I know. This is to give you a structure for securing Linux systems. Again, whether it's Ubuntu, Fedora, Red Hat, SUSE, you name it. This is basically based on precedence or risk in terms of the ordering, which you'll see here in a moment. As always, this is one of the top security mantras is trust but verify. Don't trust anything I say, but verify it. Go and check your own security checklist. Check with your Linux sysadmins. Go through your own due diligence and test. A couple of others I'll be demoing. If I have time for demos, I'll be demoing using Ubuntu. Other Linux flavors are similar. Your mileage, again, may vary. If you see the Courier new font, that means it's a Linux command, and you should be able to type it into a command prompt. I'll be running some of these as root or using the sudo command. I try not to use just the basic root su. Sometimes it's just easier if I do. Warning, you're running very dangerously if you run as root. Try to run with minimal privileges. I'm also old school. I've been running Unix for well over 25 years. Anyway, I like the terminal command line rather than a GUI. I still like to use VI. You can use Vim, Gedit, or Nano if you want. And then I do have references throughout and at the end. All right, let's jump into my checklist here. These are the top things you should consider doing when securing a Linux system. I put it into top 10 high-level steps. I'll be walking through each of these steps through this presentation. Just wanted to provide you with this high-level overview of what we'll be covering over the next few minutes. So let's dive right in. Start with number one. Inventory. This is step number one for NIST, Cybersecurity Framework, and for the Center for Internet Security Controls. Know what you have for hardware, know what you have for software, know where your data is. Be able to answer who has access to your systems, what are your systems used for, where are they physically, and where are they on your network? Why are they even around? What use are they? You got to know what you got to know how to secure it. You might have to map out your network. I recommend using a CMDB, configuration management database. Sometimes you can automate it. Sometimes it's just a simple spreadsheet with the machine name, function, IP addresses, MAC addresses, who's responsible. Often a question I will receive though is how do I generate a IT infrastructure inventory? This screen shows some tools over on the left-hand side. These are ones that I've found through my exploration. Again, your mileage may vary. Some of them are free, some are paid for, but just to give you an idea of inventory systems. You also see on your screen just Nmap. Nmap is one of those tools that should be in every IT and security person's tool bag. Should be on your thumb drive, should be one you always keep up to date and have readily available. I use it to map out my home network, making sure my kids haven't attached anything they shouldn't. Use it to make sure my neighbors aren't attaching to my Wi-Fi, etc. Know what I have on even my home network. You can leverage this on a work network as well, just to create a software inventory and hardware inventory of the different systems, along with operating systems available. A lot of commands available through Nmap. If you're a GUI person, you can use ZenMap as well. So that's inventory. Step two, command line. Get comfortable with the Linux command line and the editors. Most commands for securing the system are run from a Linux command prompt rather than a GUI. Just much more efficient. Plus, it's easier to script out. I'll talk about automation at the end of this talk. If you're learning Linux, find a good Linux command cheat sheet. I actually have a link through the slides where you can find some cheat sheets of Linux common commands. One of my favorite commands that I use on Linux and Unix is the man command. The man command is your friend, and no, it's not sexist. It's short for manual. It gives you the manual for the commands on Linux. It shows you exact syntax of other commands. So on your screen, I just did a man of man to kind of give you the idea. Again, running as root, I've already talked about. Should be very careful when doing it. You'll see I often provide the actual command prompt for each of these steps. Next step, now we're getting into actual security. Secure the BIOS with your system. So when you're initially installing a Linux system, you should take the following steps to protect the underlying hardware and system drives. First, protect the BIOS. This is when the system, your operating system, is initially booting. It's the basic input-output system. So you want to lock that down in the host with a bootloader password. I'll be discussing this a little bit later on as well. This reduces the risk to the underlying infrastructure from accidental or malicious changes. Now, some of you might say, well, my Linux servers, they're all physically secured. This provides that belt and suspenders. If for some reason physical security is compromised, someone's able to get at your physical server, you want to make sure they can't just boot up, gain direct root access on the console to the system. That bootloader password protects the underlying infrastructure. You also should consider encrypting the hard drive using Logical Volume Manager. Again, if for some reason the hard drive is compromised, you know it is encrypted. Also, when you're removing the system from inventory, if it's pre-encrypted, once you get rid of the keys, theoretically, that's a good way to clean up the back-end hard drive. You might also want to scrub it other ways. Again, I like belts and suspenders with my Linux systems. Next step, under step 3, is partition the system disks. Create separate system file directories for your root drive, boot, your user, opt, var, home, temp. This is for both performance as well as security. Then there's USB drives. If they're not going to be used, disable the port. Don't even allow it to be, so someone even accidentally plug in a USB drive. Again, it's physical security followed by logical security. If anyone tries to plug in a USB into a port on your Linux system, won't work. Now you might just come back and say, well, what if I need it? You can always re-enable it. In my back-end notes, I actually have some of the commands on how to do this that I'd be happy to share later, but in the interest of time, I'm just going to keep moving forward. Step 4, system updates. Again, it's a basic step for security, but you'd be surprised. So do me a favor, take out your smartphone, and most likely your smartphone is running some type of back-end flavor of Linux, particularly if it's Android. Anyway, is your smartphone 100% up to date? Is the operating system? How about all of your applications? Yeah, that's my point. Sometimes we're not as up to date as we think we may be. So this may seem like another Captain Obvious moment. So updating the operating system is a fundamental security step. It's often the quickest, easiest way to reduce vulnerabilities and the system's threat surface. For package installation, use one of the commands based on your Linux distribution. So like apt-get or apt is used within Debian, Ubuntu, Linux Mint. You might be using RPM if you're on Red Hat or Yum. DNF, Dandified Yum, is on Fedora. Arch Linux has Pacman or Zipper on OpenSUSE. So find the package manager that fits your distribution. Learn how to use it. The second part, so once you've updated, so you update, and I'll show some commands on how to update on my next slide. The second part of the step is to remove anything that you don't need. Remove any unnecessary software packages that aren't being used. Linux servers are traditionally single-purpose systems. Having additional software weighs them down and presents a potential security liability. it keeps your threat footprint as small as possible. So get rid of stuff if you don't need it. And I'll try to show some of the commands on how to do this a little bit later on. How do you update on Linux, on Ubuntu? Here are some of the commands, just as the example using apt-get. The different other flavors of Linux that use, say, RPM or yum, it's very similar. So apt-get update to update the system, or upgrade, list all available packages. apt-cache is one of those commands you can use to see what's been cached within this operating system. You can use it to search. So searching for particular applications. So if you want to remove any unnecessary ones, you can view them first using apt-cache. Then searching, checking your package information, apt-cache show, and then that particular package. In this case, it's the package netcat, provides all of the details associated with netcat. Moving forward on to step 5, and a little bit later on, I'll try to run and show some of these through a demo, but in the interest of time, again, I'm just going to keep trucking along. Another simple step to securing underlying operating system is to install the mandatory access control on the kernel. This protects the host system from being compromised. You can use one of two tools, either SE Linux or AppArmor. I'll talk about both here in a moment, but they each provide tools to isolate applications from interacting or interfacing with each other. Each also allows more control over access. If you're studying for security certification like CISSP or Security Plus, you need to know the difference between MAC and DAC. Mandatory access control, meaning it's enforced, versus discretionary access control, or DAC, meaning it's up to the systems administrator, it's up to the end user. This enforces MAC within the Linux operating system. I found AppArmor is a little bit easier to install and configure. So that's the one I tend to use. Note you cannot have both running at the same time. Let me explain a little bit about SE Linux. And again, I've provided some links on the screens and on your slides where you can go to learn more, because that's part of my intent through this presentation, is to give you nuggets and to encourage you to learn more about the Linux operating system. Previously mentioned, SE Linux is a mandatory access control or MAC system. It was actually developed by NSA. It replaces DAC, discretionary access, common on most Linux systems. SE Linux and MACs resolve the issue, so mandatory access control, it resolves the issue by confining privileged processes and automating security policy creation. SE Linux defaults to denying anything that is not explicitly allowed. So note that if you were running SE Linux, you could accidentally cause your own denial of service, because it denies anything that you don't allow. So you'll need to specifically allow things through SE Linux. SE Linux uses two global modes, permissive and enforcing. Permissive mode allows the system to function like discretionary access control system while logging every violation to SE Linux. So it'll allow, but just provides logging. So it acts more like an intrusion detection system rather than intrusion protection. The enforcing mode enforces a strict denial of access to anything that isn't explicitly allowed. To explicitly allow certain behavior on a machine, you, as the sysadmin, have to write policies that allow it. I could spend a lot more time just on SE Linux and locking it down. This is one of those tools and applications as a security or sysadmin on Linux systems you should be familiar with. See Linode's Getting Started with SE Linux guide to learn more about SE Linux. The other tool for mandatory access control that I briefly mentioned earlier is AppArmor. AppArmor is included by default with Ubuntu. It's similar to SE Linux, and while they work differently, both provide that max security. It, in effect, allows developers to restrict actions processes can take. So you can't have a process that runs out of control or is used to perform some feature or function that it wasn't meant to be used for. It does run silently in the background, so you might not even be aware of what it's doing. That's actually some of the best security, is the quiet security. AppArmor locks down vulnerable processes, restricting the damage security vulnerabilities in these processes can cause. You can also use it to lock down applications like Firefox for increased security. So I'll run AppArmor to kind of put a sandbox around Firefox. So even if I go out to a malicious website on accident using Firefox on a Linux system, really limits the damage through AppArmor. To view AppArmor status, you can use sudo appArmor_status or AA-status is the command. Go to the Ubuntu site to learn more about AppArmor, as well as How To Geek. I provide their resource as well. By the way, I love How To Geek. I'm always on that website learning about many different aspects of being a geek. Moving forward with step 6. Briefly mentioned earlier about locking the boot directory. See, the Linux boot directory contains critical files related to the kernel. So you need to make sure that this directory is locked down, set to read-only permissions. This prevents accidental or malicious changes. To do this, you edit the what's known as etc fs tab, and I show the specific command on how to do that on your screen. You also want to look at password protecting the grub bootloader. This restricts damage of physical or bootloader access, works in line with the previous steps, step 3. You may especially need to do this with some older Linux OSs. Another part of this step is disabling unnecessary applications from starting. So in step 4, I talked about removing those packages you don't need. But let's say you still want to keep a package. You just want to make sure that it's not running by default. You have to explicitly allow it to start. The concept here is to go, you can use service status all to see what is running. What are all the different services running within your Linux system? And then remove it from starting within the inetd. By the way, inetd links to, or rc runlevel.d links to inetd. This is the directory within Linux where it shows everything that'll auto star. You can also disable items from automatically starting, use the system control command. So it's systemctl, not system control, but it's systemctl disable, and then the name of the service is the command. So let's say you you don't want your users to be using email from your Linux system. It should only be sending out email. No one should be using a Linux system to read email, for example. So I would use the system control, systemctl to disable email, anyone from being able to read email on my Linux system. Step 7, I told you we were going to be rocketing through each of these steps. Securing the network layer. So we're securing the base operating system. Now we need to understand what is connecting to our Linux system. To view the hardware associated with the Linux system, that's the lshw-class network command. Displays the network configuration at the hardware level. Then you can use the basic if config to see your IP addresses. A firewall won't necessarily stop everything, so you want to secure your network from the inside out and not solely rely on a firewall. Other steps you can take is to create a default gateway. That way, there's no other gateways that can be used for outgoing or incoming communication, network communication, to your Linux system. You do that by editing etc network interface file. If you're not familiar with Linux, by the way, the etc or etc directory is where most of the configuration files reside. Good idea to get very familiar with what is contained within the etc directory. Another consideration for securing a network are DNS resolutions. Traditionally, the resolve.conf was a static configuration file that rarely needed to be changed or automatically changed by DHCP client hooks. So keep in mind, as you're looking at setting up your IP address, maybe you want to use a static IP address rather than dynamic. Do you really trust your DHCP server? And that's part of the network configurations you should be considering as part of your Linux lockdown. For locking down and securing DNS, I recommend setting some specific DNS servers within your infrastructure. That way your Linux servers cannot, you're reducing that possibility of DNS poisoning if you're always pointing to your trusted DNS servers. The systemd resolved command handles that name server configuration, and it should be interacted with through the systemd resolve command. The net plan configures the systemd resolved to generate a list of name servers and domains that are automatically put into the resolve.conf file. I also look to secure my network through disabling IP forwarding. This ensures that a server with multiple interfaces, for example, a hard proxy, so there's multiple NICs on the system, will never be able to forward packets unless I explicitly allow it, and therefore never can serve as an inadvertent router. I also looked at disable ICMP redirect acceptance. That way, my server, Linux server, cannot be used to maliciously craft ICMP redirect messages and cause a denial of service attack on my internal network. If ICMP redirects are not used on the network for route updates, and if the server is not acting as a router or gateway, then ICMP redirect send and accept should be disabled on your Linux system. Last is to ignore ICMP or broadcast redirects. And that's by adding some specific lines in the etc sysctl.conf. So that's /etc/sysctl.conf is the file. There's specific commands you want to add into your sysctl.conf to ignore ICMP requests and ignore broadcast requests. I'll also edit it to disable send packet redirects as well. Again, you can't rely on a firewall to do everything. There are certain ways to lock down your Linux server's network. But speaking about a firewall, let's talk about firewalls briefly. First is the uncomplicated firewall that comes with Linux. You can make sure it's started. So UFW is the Linux system firewall, provides that extra network protection. UFW is an interface for IP tables, offers an easier way to regulate incoming and outgoing traffic. You enable it with the UFW enable command. Depending on what you want to allow through, you can then change it as well. You see other commands regarding UFW on your screen. Linode again has another good article, this one on how to configure a firewall with UFW. If you're not familiar with it, check that out. Review how to leverage UFW as one of the tools that are already in your toolkit you can use to secure your Linux system. IP tables is the back end for UFW. You can also use it to secure your Linux networking configuration. To view what is currently allowed, it's the IP tables -L command. IP table connections has specific responses. So you can choose one of these three responses for IP tables. First is to accept, allow the connection. Second is to drop the connection, act like it never happened. This is best if you don't want the source to realize your system even exists. You can use Nmap to trick firewalls to show that systems, whether they are accepting or rejecting packets. If packets are just dropped, then your backend system won't even be seen through the firewall. So that's when you might want to use drop. The third option is reject. Don't allow the connection, but send back an error. This is best if you don't want a particular source to connect to your system, but you want them to know that your firewall blocked them. More information about IP tables is available from the How To Geek article, Beginner's Guide to IP Tables. Step 8, access and authentication. This step reduces the threat vectors associated with user level or admin level access on the Linux system. First part, review all the users established by default and disable or remove any that are not needed for the functionality of the systems. Make sure any users you do need have a password. What you can then do is use some type of a password vault for those passwords for any accounts that are required for systems administration. I'm talking about sysadmin level accounts. Second step is to configure authentication settings. If you install SE Linux or AppArmor, this is included with those packages. If not, you'll need to modify the pluggable authentication modules, or PAM, configuration files found in etc pam.d. You can also use PAM with a centralized LDAP service. The PAM module is used to set the security policies of the Linux host. To set password policies, open etc pam.d common-password and etc pamd system-auth files and change the settings to match the policy for your organization. You also want to look at reducing the root access, reducing root use. Root is super user. It's the administrator account for Linux. On Ubuntu, it's locked by default. I recommend you actually set your root password and then you lock it up in a physical safe. You set it very strong. That way it's reducing root's godlike powers on the system. You have it in case of emergency. So actually where I worked previously, we called it a fire ID, only unlocked in case of fire. You should be using sudo, which is a native Linux structure to allow specific users access to run specific commands. You edit sudo capabilities using vi sudo, and you can allow specific users to only run very specific commands using sudo. I don't recommend keeping everything at all. It's one of the defaults set. By default, it's on the Linux system. Change it. Only run what you need to run. This is the whole concept of least privilege. Permissions on a Linux system tends to be the kind of bane of our existence. Often when I run into challenges in administering a Unix or Linux system, it's because of systems, due to permissions problems on the systems. First is to lock down the system files. Put them to read-only status if you can. Set the owners to root, making sure there's no other owner that can change the file. Again, prevents inadvertent changing of critical system files. Set the permissions for securing the boot settings, previously mentioned, the grub bootloader, changing the owners. Require authentication for single user mode. Set permissions on configuration files like your SSH configuration. I'll talk about SSH here in a moment, or even within cron. Cron is what's used for scheduling within Linux systems. The permissions and access, basic step that is often overlooked within Linux. Step 9, securing remote access. You see how to view open ports and services. You can also use Nmap for this. Disable any remote access such as Telnet, FTP, all of these old things have been around with Unix forever. The R commands like rlogin, rshd, rcommand, rexec, disable them all. Use SSH instead. The commands on your screen show how to change these configuration settings and disable them by default on Ubuntu, Debian, and then Red Hat and Fedora. Use SSH instead. Configure SSH Secure Shell for remote systems administrator access. The question is how are your administrators going to get access to that Linux system? They should be doing it through maybe even an SSH gateway. You should only allow specific and limited users to have this level of access. You also need to properly manage the SSH keys. On your screen, you see the steps for actually generating SSH keys. Once again, if you're not familiar with this, do a man of SSH key gen. Shows you the algorithm used, the strength of the algorithm. SSH keygen will create your public-private key pair and save it on your local system. You can also add your SSH key to the SSH agent. You may want to copy your public key up to a server, or you can add it to the service provided through Ubuntu One. You should configure your SSH on your Linux system from the default configuration settings. Consider changing the default port from port 22 to something else. For example, port 22, well-known port for SSH. It's security through obscurity, I get it. Makes it that much harder. That way anyone scanning your network won't be able to see SSH is running on your Linux system. Make sure root cannot log in remotely. You see the command on the screen, and only allow very specific users through the allow users configuration setting, which is found in SSH config file. Many other settings you can set within the SSH config file you should consider. For example, use PAM. How long do you keep the client alive? Do you automatically expire it after period of time? Do you allow GUI or X11 forwarding, etc.? So walk through your SSH configuration file, another good step for Linux security. Step 10, auditing and logging. You can't secure everything, so it's equally important to establish auditing, logging, and monitoring. The first step is to ensure the audit daemon, audit D, is installed and started. Next, set it to watch important files for changes. So I have my audit daemon watching everything in Etsy and alert me when anything changes. This will also keep logs of who modified them and when using the audit control command. You see numerous other associated commands with auditing: audit control, audit search, and audit report commands. Sometimes it's hard to watch everything on the local file, on the local system through the files. So you might want to consider forwarding the logs. You can use syslog to start a remote syslog daemon, create your own log server. So configuration is required on the Linux log server through the syslog daemon by modifying Etsy rsyslog.conf file. You can then use audit D to output client logs on a remote host using audit dispatcher. So you see the audit D configuration settings. Learn more by going to rsyslog.com. You probably don't want to go onto each of your Linux systems to watch the log files. I mean, it gets rather tedious to tail var log. I recommend using a tool like LogWatch to automatically watch the logs for you and send alerts as it sees a potential anomaly. LogWatch automatically provides daily log summaries in the server's var logs directory, which can also be sent to your mail folder. Refer to the LogWatch configuration file to change the level of detail and specific services monitored. Some bonus information now that we've locked down our Linux systems. You saw the top 10 steps in my list for a Linux security checklist. Wouldn't it be best, rather than going through this on each server, to automate? Methods to do that: one is just shell scripts. You can create your own bash shell. using the commands I showed on the screens through each of the steps. You can also leverage the Center for Internet Security baselines. They actually have benchmarks for Debian, Ubuntu, and Red Hat. It's their list of controls to lock down Linux servers. There's also the Department of Defense STIGs, the System Technology Interface Guides. These are those guides you can use to lock down Linux systems. You see the link on your screen. Lastly is to use a tool like BeyondTrust Power Broker to help automate who's doing what, when, where, how on your Linux system, and to lock them down, lock down your administrator access. On your screen, you see a few of the references that I've used in creating this. There are many more out there. Leverage these to help lock down your Linux servers and Linux systems. In this short webinar, I touched on some of the basics of Linux hardening, a bare minimum of what should be done on each Linux system. There are many more complex configuration settings to get to that next level of Linux security. My wish is that you found at least a few nuggets to use on your Linux systems for better security and better system efficiency. At this point, I'll turn it over to my friends at BeyondTrust to explain how PowerBroker can save you time and headaches in managing your Linux systems. Sarah, back to you.
Hello, this is Dave Grendis. Actually, I'll be taking the demo here.
Thanks, Dave.
Yep, no problem. Let's make sure we're sharing out this screen, people. Yep, okay. I've got a few slides I wanted to touch on. I'll be going pretty quick as well, and really just to introduce you to what our PowerBroker server suite is. That contains two primary focuses. One is logging the user into the system, allowing access to that system using an AD joined account, or essentially an Active Directory account. That's called PBIS. And then we can talk about least privilege or privilege management, and that's where PBUL, or PowerBroker Unix and Linux, comes into play. But before we hop down there, I just wanted to highlight that's not all we do. You can see we've got a PowerBroker privilege access management platform. Within this platform, we'll handle that enterprise password security use cases. We just talked about securing these and using key authentication on these Linux hosts. Well, now we have a programmatic way to rotate these keys and root account passwords, securing them in a vault. So rather than putting them on a piece of paper in an actual vault, now we have them electronically stored, and this gives you the flexibility to rotate them on a regular schedule and after their each use. Endpoint privilege management, we're going to spend any time talking about this, but that's the whole concept of not allowing your users to be local admins. All of those endpoints throughout your organization represent attack sources. Once you compromise that, move laterally across the organization and move on up. And people are trying to move up into these servers, and that's what we're going to focus on for the next few minutes of the demo. Just want to give you a quick introduction to what we do. And that'll be Unix and Linux privilege management on the server side. So controlling access to the hosts, and then controlling, once you've gained access to that host, what can you do on that Linux host or server. We're going to do all of this through, make sure I didn't skip one. Yep, we're going to do all this using PowerBroker. And this is our PowerBroker management console, which is a GUI-based tool that allows you to deploy, can make configuration changes to your deployment of your PowerBroker suite of products. Just keeping in mind, everything that we can do within this UI is also available through the command line CLI and works perfectly well when automating builds of systems and so on. We add the UI a little later. So if you're old school and used to the command line, that's really the way we are as well when it comes to that. But we do have this UI. So I've talked about PBIS, PowerBroker Identity Services. The whole point of that is to allow you to remove away from users logging into their hosts using, say, local Etsy password. You can think of it, if you're already doing something like an LDAP directory, it would be using that same concept, only allowing you to use Active Directory. So the thought is one directory, access your Windows systems based on your authorization. That same directory, that same human has that one account and and they can use that to access their Linux hosts. And we're doing so in a Kerberized manner. So this is a very secure way approach, and in many cases can eliminate the need for keys, depending on what you're looking to do. Then we've got, now that I'm on the host, that's where PowerBroker Unix and Linux comes into play. It's really there to replace sudo, but it performs similar actions, but it's going to give you a whole lot more granularity. And in addition to adding the granularity as to who can do what, where, and when, will allow you to, of course, audit and track who has done what, where, and when. And really the whole idea here is to allow more of an enterprise class scalability and manageability, and of course a solution that's commercially supported. Those are all keys between, both AD bridging, key reasons why people will go with Beyond Trust for your AD bridging, as well as for your least privileged command control. And what do we bring to the enterprise table? Centralized policy management, centralized logging of who's doing what. We can even get to the point where we're going to audit events, who ran what command, where, and when, including sessions. Okay, what did I do within that entire session? Your input and output of that can now all be logged, audited, indexed even, and queryable. And so the whole point of this too is to become highly scalable without much effort needed. We'll bring to the table, of course, the ability to do analytics across who's running what commands, where, and when, giving you, insight into these logs that we've been collecting. And then real quick, what I wanted to talk about was, and this is one of my last slides here, is really the architecture of the system. Now we're gonna set PBIS, our AD bridge, aside. That's just logging onto a host. Once I'm on that host, it doesn't matter if you came in through Etsy password, an LDAP directory, or PowerBroker identity services. Once you're logged on, we want to control what you can do in an elevated manner, and that's what PBUL will do. And there's three main components to it. We'll have a client that's installed on your client, and that's referred to as PBRun. When we prefix a command with PBRun, rather than say checking something like the local Etsy suitors file, we're going to go out to a central policy server, and a lot of this is key. This is where we've got large advantages, say, over what you might see in the open source world. In that this policy now is no longer, we're not giving the user root access to anywhere where policy is configured. So we're not looking local and allowing them to make modifications there. Additionally, all the event logging and session recording is not being captured on the host where the commands are being run. We actually capture all of that ahead of time and then instruct our third piece here called PBLocalD. That's the agent that's going to run the commands on behalf of the user. We instruct it to run the commands, delivering the output to the end user who is initiating that command. So this creates an indelible audit trail, even when providing someone, say, complete root access on a particular host. Now, that's not necessarily the way we recommend starting off. Of course, we like to do a more of a least privileged type of deployment. That said, obviously, there are times when you don't necessarily know what those privileges might be. So I'd like to start off with, so we can elevate and give you an entire shell as root. To start off with, though, we're going to head into the web UI real quick and show what some of this policy looks like. That's not the password. So this is that PowerBroker Servers Management Console. To start off with, we have a nice dashboard view, what's in my environment, what's installed with PBUL, identity services, and so on. We can use this tool to go out and discover Linux hosts across your environment. Of course, we change those default ports, make sure you recognize that here as well. And finally, when we come on down, here's a list of now the various hosts I have in my environment. Are they domain joined? Can I log on with my Active Directory accounts now? And now where the area where I'm going to focus with here is going to be PowerBroker Unix and Linux. Is it my policy server, logging server? Is it a client? And so on. So I have that view here. And this is where we would come and use this tool to also deploy new systems if we needed to. And then finally, what I wanted to show in here is the different types of policy. And then we'll exercise some of these. Now we do have what we call script-based policy. That's a little more along the lines of what you might see with sudo. In fact, it goes well beyond that. And some of the advantages of there is even within the policy itself, you can make system calls. And what that means is now we can use data-driven policy. I don't have to come in and modify or maintain users within or command sets within my policy. I can maintain them in those external systems. Those are just some of the key areas that script-based policy can become very powerful. But for a more simplistic approach, we also have and find that roles-based policy can allow you to very quickly create roles and allow users in particular groups to run various commands across your systems. So for example, here's my Oracle role. This one is pretty basic. I say who, what, where, and when. So Amy and Carrie can run these commands. This list of groups right here is completely configurable. These can be local groups, local users. These can be Active Directory based groups of users or Active Directory users. In this case, the run user isn't root. I've chose to make the run user Oracle, of course, for obvious reasons. And then where and when. This is something that's also a very cool concept within PowerBroker, Unix, and Linux is the idea of remote command execution, where I can define what hosts I want these commands to be issued from and submitted from, and which hosts the users are actually authorized to have the commands execute on. Meaning I can run commands on, say, a host that I have logon rights to, and PowerBroker, Unix, and Linux will then allow those commands to be run on the remote hosts without ever even having to allow the user to SSH to it or even touch that host. And of course, all the time we'll audit this information. That would be sort of a more defined, let's look at what's in that command. So there's one role. You can see I've got some for Docker as well. Tier 1 admins, AWS type of admins. So it can be both at the system level, allowing someone to run bash or run command line tools, or even within, if you do have an application that's a command line app, you can even put these types of controls in here. And I'm not just giving users the ability to do everything. One of the things that you get with PowerBroker, Unix, and Linux is the ability to control not just the command that someone can run, but the arguments associated with them. So for example, AWS IAM. Well, right now, this user can run AWS IAM then anything. So that means that they can't get into everything that AWS CLI gives them. They can only get in and manage everything within the IAM component of that URI, and so on. Similar with, I did some of that with Docker as well. And you can control and create your own types of command sets. So for example, Docker show executes a very specific command. So if in traditional world, if I were to give someone access to, say, the Docker using sudo, the Docker binary, and run that as root, well, then they can do anything. But that's not what we want. If you give someone CP, the ability to run CP as root, they can own the box if you don't tailor the arguments as to where they can copy. So those are just some examples of what we can bring to the table. And then, of course, we'll audit what took place. So to show it in action, we'll go ahead and quickly jump right here, open up a host, head out to my Oracle box, say on Lin 7. I'm logged on. I was single sign-on in there with a Kerberos ticket based on my AD bridge, PB run, and then we'll do, what did I even, we were heading to, lost it there. We're not gonna do Docker, Oracle, SQL plus is what we'll do, PB run, SQL plus. So we can see here, now I put this dialog in, by the way, but this is going to allow me, based on that Oracle role, we're gonna run this command as Oracle, and obviously we have. I'm logged in here as Oracle. If I do something like select all from all underscore users, I can now run these commands just as I would. I don't know the Oracle password, don't need to know it. And in this case, I am logged on to that Oracle host. Having said that, you can still use that remote command execution as well in those cases. And all of that's going to be audited both at the event level and the IO log level. To show, say, more of an open-ended one, Carrie can do something like PB run bash. Now, even in this case, I'm going to audit everything Carrie does. You know, if we go into vi, etc, psswd, pass, see if we can get that right. We did. This will be captured. If I add account, don't add account, the mere fact that I access this will all be captured. And so we're just going to exit out of that session there, given the fact that we don't have too terribly much time. And I want to finally just pop back over to that web UI and show. And again, everything that we're going to show right here from this audit trail is also going to be visible through through the command line if you want to, and we can send it off. We have a Splunk app and so on if this isn't the app you want to use. But at the end of the day, we can see right here, not too long ago, in fact, we can refresh it, that was a little bit earlier. Here's that bash session from Carrie. I can even query across all of those keystroke logs are indexed, but here's where Carrie went in and ran the who am I command and so on. If we close out of here, I have an event view of this information as well. You know, who's run, what commands on what hosts, where and when. That's my password safe actually going out there and rotating my root account passwords. We'll see if we've got the new one that's just come in. Not quite yet. These do take a good minute or so to filter into the system, but we do a refresh here. And just to show you what that SQL Plus session looks like, I can take a look at that, where Carrie went in and ran those commands unsuccessfully in some cases there. And that's basically what I wanted to show, sort of to entice you to hopefully look for another demo, and we can go into all the various use cases that you might have and how we can help with those. But the takeaway is centralized authentication, logging onto these hosts rather than having to create hundreds of identities just to log on to 100 servers. And then centralized policy control and auditing of commands. So allowing a central place to allow people to elevate and just run the commands they're authorized to, all the way down to the argument level, as well as then once they've done that, audit what they've done. That really concludes the portion of my demonstration. I wanted to send this back to Sarah so that we can.
Perfect, thanks. And that actually is a perfect transition for our poll here. You should see that pop up on your screen right now, folks. And if you would like to schedule a more personalized one-on-one demo or a deeper conversation about PBUL, any of our Power Broker products, even Retina, our vulnerability management product, please select yes, and then somebody will reach out to you directly and schedule that personalized demo and have that conversation with you so you can really get into the nuts and bolts of the product and spend a lot more time seeing it in action. So I'm going to leave this up. We've got just a couple more minutes left. So Ron, I've got a couple questions that came in for you. So jump on off of mute and let's dive in. On a fresh Ubuntu install, what are additional packages like add-ons that you like to install?
Good question. Some of the go-to packages I use are the Unity or GNOME Tweak tool. It provides users with the ability to configure their system in a way they want via setting options that include desktop hot corners, icons, etc. There's other tools like NeoFetch that displays information about your system next to the ASCII operating system logo, or even Atom, which is an open source text editor, using that instead of VI. I also like the ability to take screenshots. So I'll sometimes throw on Shutter screenshot and annotation tool as an extra package, just so I can, if I need to be able to prove what I'm doing on the Linux, I don't have Power Broker, for example, I'll use Shutter because it's kind of the equivalent to Snagit or the snipping tool on Windows. So those are just a few. There's a lot of other really good packages, and I love swapping and sharing notes with others to hear about their top packages they use on Ubuntu.
Dave, a question for you. Will PowerBroker work on a laptop when the end user is traveling and not directly connected to the corporate network?
For that, we would use a different tool, probably something like PowerBroker sudo. So PowerBroker, the way it's meant to work is if we can't audit it, you don't get root. So it's really meant for these critical systems like that. So for example, if we don't have access to that central audit trail in that central auditing server, then when someone types pbrun and tries to get root, we're not going to do it. You would never will let anyone have root if there isn't an audit trail behind it. So the short answer is no. Having said that, if you're looking for least privilege on the laptops on a Linux host, we can definitely help there as well for some centralized management of solutions. But we might use PowerBroker sudo in that particular use case.
Okay, guys, it is the top of the hour. I'm sorry we only got to 2 questions. We just had a lot to cover today. So let me remind you that we will be sending you a follow-up email. It will contain links to the recording and the slides shown here today within 1 to 2 business days from now, and it will come from communications@beyondtrust.com. So be on the lookout for that follow-up. You can refer back to the recording or share it or watch again, whatever your heart desires. And a big thanks to our experts, Ron and Dave, today. Thank you guys so much for being here and covering a lot in 60 minutes. We really appreciate it. We could run probably a whole day seminar talking about this stuff. So appreciate you cramming this in. And to everybody who else attended live, thank you for being here. Have a wonderful rest of your day. We'll see you guys at our next one. Take care, everybody. Goodbye.